Hello everyone. This is part 2 in our series about presentations about militarized interstate disputes. And today we'll be looking at how the correlates of war MIDS dataset can help us answer our questions about militarized interstate disputes. So a brief reintroduction. Militarized interstate disputes are instances where states threaten, display, or use force against one another. And we want to answer two questions, which is, what is the relationship between the quantity of disputes between two dyads and the probability of escalation? And two, how does the duration and the history of MIDS between two countries change the probability of escalation? So we forwarded two hypotheses, which are that, first, states that rarely engage their MIDS are the least likely to go to conflict, most likely because they're less likely to have conflicting interests or territorial claims that compete with one another. And second, states become more likely to escalate up to a certain point, but then the likelihood of escalation decreases and levels off because of effective signaling. So we talked about the theory of resolve in our introduction to our research paper, in which we state that the reason that states go to war with one another is because they misperceive each other's threats and actual willingness to go to war, as well as their capabilities. They miscalculate. And that is because war is a mutually undesirable outcome, so states will want to threaten it without actually being serious on their threats. But if countries engage in MIDS with one another, then they're more likely to understand each other's capabilities more and how serious they are on their threats, at committing to their threats for going to war, because MIDS are a costly signal that demonstrates that whatever they're fighting over is something of value. So our dataset is the Correlates of War Dyadic MIDS 3.1 dataset. So how all the Correlates of War datasets are collected is that each dataset is divided up between different universities, and they're assigned at maintaining the dataset, at conducting historical research to update the dataset over time, and to correct any errors, and to keep it in shape, essentially. It's probably the most prominent dataset in this field of international relations research, especially for dyadic militarized interstate disputes. This particular dataset was compiled in 2019, and basically narratives are created by historians through historical research, and they assign the different values to different variables. And whenever an error is found, feedback is given, and those are always updated in the next edition. And there's quite a lively debate on, whether or not certain things are coded correctly, etc., which makes the dataset pretty rigorous. So here's some characteristics of the dataset. The dyadic MIDS dataset is separated into data points that are dyad disputes, which means that for every militarized interstate dispute that happens, an entry goes in for each pair of dyads that were a part of that dispute, which means there are around 10,000 data points and 4,000 actual disputes. These disputes occurred between 1816 and 2010. Some modifications I had to make to the dataset. First is that I introduced dyad ID numbers for each pair of countries. So for example, the United States and Japan might have an ID number. And the basis of my research question requires examining the history of militarized interstate disputes in previous years. So I thought about the ways to do this, which you can imagine is an issue since the data points themselves are just particular disputes that don't really retain information about the history of disputes between those two countries. What I ended up doing was coding another variable for each dispute of how many times those countries have been in disputes in the past 10 years, excluding the dispute that they're currently in, or the dispute that for each dispute you have a 10-year period before it, and it counts the number of disputes that are in that 10-year period. And so far, for the variables that I've considered, which are the escalation variable and the countries involved, and the count, there haven't been missing values or invalid values, since it's pretty important to get the countries that are in the dispute correct, and the year of the dispute correct, and whether or not they escalate to war correct. But I can imagine that I'll have to account for those as I start introducing the other variables that I want to control for. So here are the relevance variables. The dependent variable is escalation, which is just binary. The independent variable is the number of MIDS in the past 10 years, which we described previously. And the control variables are the average intensity of the MID / fatality level, how the MID was resolved, and a bunch of different structural factors between those two countries, like contiguity and power parity. So there are two categories here that we want to control for, which is the quality of the MIDs and the quality of the countries. So we'll talk about how we control for those in our plan for analysis. But first, let's look at the dataset's preliminary results. So this is a histogram of the number of previous dyadic disputes in a 10-year period. So a country has a dispute, and we count the number of disputes that it's had in the past 10 years. The mean number of disputes is 2.3 3.218, and the median number is 2, which means that we can tell it's a distribution that skews towards the higher end. And you can tell it's got a sort of a asymmetric, like almost Pareto property, in which most countries that end up engaging in disputes have not done so in the past 10 years. Or not most, but rather more than a plurality of them. It's actually less than half. And we also look at the proportion that escalate into war. So it turns out that 86% of them are not wars, and 14% of them are. And war is categorized as a dispute that has 100 battle deaths or 1,000 troop deployments. So it's sort of significant. Next, we look at the histogram that we looked at previously, but we split it up into disputes that ended up being wars and disputes that did not end up being wars. So we can see that the means are sort of similar at 3.2 and 3.30 respectively, but the distributions are different. The disputes that occur between countries that did end up going to war, they're more likely to have 1 or 2 disputes before they end up going to that point. So there is sort of a build-up to it. Whereas disputes that did not end up being wars, there's usually not much of a build-up to it. As in, 30% of disputes that did not end up going to war end up happening between 2 countries that did not end up going to war. So this doesn't necessarily support our hypothesis, which is that when countries engage in mids, they find out more about each other and less likely to go to war. But it doesn't necessarily negate it either. This graph tells us a little bit more about our hypothesis specifically. It plots the proportion of countries that end up going to war with the number of disputes they've had in the past 10 years. And you can see that countries that don't dispute at all and haven't in the past 10 years are about 10% likely to go to war. And this number peaks at about 4 disputes in the past 10 years, where it's almost at 25%. It's actually about 0.22. And it sort of levels off from then on. And you can see that countries that engage in 25 disputes in the past 10 years are not very likely to go to war at all, but also that the data becomes less and less confident as we move along the x-axis, because there aren't very many countries that are engaging in 20 or 25 disputes in the 10-year period. So here's what we're going to do from now on. We're going to have to come up with a way to control for a lot of control variables that aren't in the data set. So my idea is to manually mutate for every single pair of mids, contiguity, whether they board each other, power status, whether or not they are a high power, low power pair, a low power pair, or a high power pair. So there are actually 3 values there. And democracy. So if it's 2 democracies, a democracy and a non-democracy, or 2 non-democracies, which are the 3 most important factors as outlined by Stuart Bremer that contribute to going to war. So the second thing is that we'll look at dispute factors. Now here we run into another issue, which is that if a country has 10 disputes in the past 10 years, then goes to war, we can't really retain all the information about all the disputes that happened before it, right, in the past 10 years, or rather we don't want to. So my idea is to assign a numerical values to every category of these variables and create a sort of average outcome, which isn't necessarily the best because a lot of these categorical variables aren't interval variables, which means the average might not signify a lot, but it would still be valuable to control for. And the variables that we'll probably look at are dispute outcome, dispute military confrontation levels, and how many people were killed. And we can come up with averages for those for the history of disputes that leads up to a potential escalation. Next, we'll look at several models. First is that we'll create a regression between wars and the number of disputes in the past. Then we'll look at the regression between the number of past disputes and the factors of the disputes themselves, average dispute factors being the type of thing that is discussed on the previous slide. And the third one is that we'll consider those 2 variables and also add in the structural factors, which may or may not be necessary since the factors that tend to lead to war are also the factors that tend to lead to militarized interstate disputes. And the fourth is that we'll look at just the probability of war based on these structural factors, which you'll see is important in the next slide. So this is the table from Dangerous Dyads by Stuart A. Bremer in 1996. And essentially what he did was, for each variable, for example, contiguity, he calculated the conditional probability of war for everything, war for that country based off of the characteristics that were related to its contiguity with another country. And then he compared that to the proportion of countries matching those factors that actually ended up going to war. And he assigned a z-value to it and calculated its statistical significance. So if we expect 2 countries to go to war not very often, but they end up going to war very often, and we controlled for everything except for militarized interstate disputes, then the idea is that the difference in those, the proportion and the probability, is a result of militarized interstate disputes. So that's a methodology that I'll be trying to emulate. Some concerns I have. Well, there's a possibility of missing data in the future for when I eventually code these variables, code the uncontrolled for these variables. Second is that to answer the second research question, we sort of need a good quantitative measurement for the difference between two countries that are fighting wars forever and just fight over and over and over again, but never, do anything extremely serious about it, and rapid escalation, which is countries fighting a lot of mids in a very short period of time, and then that ends up leading to escalation in war. Also, I'm considering what type of regression models that I'll be using for the purposes for the regressions that were listed 2 slides ago. I was looking at probabilistic regressions, since war seems to be a variable coded between 0 and 1, and just determining the conditional probability of war, because I'm not very well versed in those statistical methods. But yeah, that's my presentation. Thank you for listening.